Welcome everyone. Thank you so much for joining us tonight. Just to let you know, we are recording tonight's event. Thank you for joining us. My name is Christopher Crockett. I'm one of the board members for the DC Science Writers Association, and tonight we are thrilled to be chatting with science journalist Ashley Yeager, whose recently published first book, Bright Galaxies, Dark Matter and Beyond, tells the story of astronomer Vera Rubin, whose observations of how galaxies rotate were crucial to convincing researchers that the universe is overwhelmingly made up of some type of invisible matter, or dark matter, that does not emit any light, but makes itself known only through its gravitational pull on stars and galaxies. And if I can quote from Ashley's book, I think Vera Rubin herself summed it up best when she was giving a talk to a room full of colleagues in 1985, and she said, "We thought we were studying the universe, and we now know we were only studying a small fraction of it." Very cool. Well, Ashley, thank you so much for joining us.
Thanks so much for having me, Chris. I'm really excited to be here, having been a former DCSWA, but maybe always a DCSWA, I guess.
Always a DCSWA member. So I want to start off with just asking, why did you want to tell Vera Rubin's story?
So it really started, I guess, just after undergrad. I was working at the Air and Space Museum in DC and was just walking around one of the exhibits and was noticing that there weren't a lot of stories about women in the exhibit, and came across just a small placard about Vera, and it talked about dark matter, and dark matter was something that I had never heard of before. I had taken a couple of astronomy classes, but we hadn't gotten that far yet. And so this was an idea that kind of blew my mind, that like most of the universe, we don't understand. We don't know what it is. It's dark, it's mysterious. And somehow this woman helped convince the astronomy community that that's how the universe is. And so I was immediately intrigued. And I started asking my supervisor, because I was an intern at the time, a lot of questions. And he asked me if I wanted to interview Vera as part of a project that he was working on. And so, of course, I was like, oh, yeah, that'd be great. Sure. And so that kind of started my introduction to her and learning about her story. And then, ultimately, it was years later that this book project came about. And I think what I realized was I really wanted people to become engrossed in her story in the way I had. She really kind of pulled me into thinking about the universe and thinking about these bigger questions about what we do know and don't know about this crazy universe that we live in. And so I thought that her story would be a great gateway for other people to start to ask those questions themselves.
See, I want to just kind of piggyback on what you just said, how her story really pulled you into the craziness that is the universe.
Yeah.
What was it specifically about her story that did that?
I think there were a lot of different threads to pull on. I think the first one just was the idea that, as she said, like, we really don't understand a lot about the universe that we're looking at. That was something that caught my attention. Like, wow, how do we, we have these telescopes and we have these great instruments to study the universe, and we still don't know a lot about what it is. So that was the first thing. And then the second thing was really kind of putting together the idea of when she was doing her work and kind of when she was a student in astronomy, and going back to the idea that she was really kind of just getting her start after World War II. And at that point, there weren't a lot of women in science, and it's still an issue that we face, having women in science, specifically in physics and astronomy. And so I thought that would be something interesting to explore, as well as really what made her successful, what made her be able to make these discoveries.
Great. I just want to remind everyone who's listening in, if you ever have any questions you want to ask Ashley, please use the Q&A button down there, and we'll definitely get that question to Ashley. So for people who aren't astronomy nerds like me, like you, what exactly did Vera Rubin contribute to our understanding of the universe?
Yeah, so I think we have to take a step back and kind of really look at the light we can see in the universe. She really got her start looking at stars and galaxies. And her basic question at the beginning was really, how do galaxies rotate? How do they spin? Other things spin. So what's really going on there?
Mhm.
And what she noticed was that a lot of people were looking at the stars near the center of a galaxy and looking at how they orbited the center of the galaxy. How did they move around it? And her question was, okay, well, that's been done. A lot of people have done that. What happens when you start to look at stars farther out from the center? And so there had been this assumption that those stars would move more slowly around the center of the galaxy. It's kind of like looking at Mercury and Pluto going around the sun. Mercury goes super, super fast, and Pluto kind of plods along. And yeah, I mean, it's got farther to go, so it takes longer, but its actual speed around the sun is much slower. And so there was just this assumption that that's what stars would do too. And she said, okay, well, that's a great assumption, but let's collect some data. Let's actually see if that's true. And so as she started to pull on that, she saw that the velocity, the speeds of those stars were really, really fast. The ones farther out were moving just as fast as the stars closer in. And that is what I think kind of shocked a lot of people. Like, this isn't how this is supposed to work. This isn't how gravity is supposed to work. Mm-hmm. So, of course, when there's a big claim like that, people are like, oh, no, that can't be true. There must be issues with the data. You must not have looked at all these other types of galaxies, or you must have done something wrong. And I mean, Vera was the type of person that she took that to heart. And she was like, okay, well, if that's the case, then I'm going to look at other galaxies, or I'm going to find data on other stars. And she just kept going to all these different galaxies. Well, not physically going. She was obviously at the telescope looking at stars in these other galaxies. And she kept seeing the same thing. First it was in our neighboring galaxy, Andromeda. Then there were 10 other galaxies where the stars farther out moved the same velocity as the stars closer in. Basically what she called a flat rotation curve. Astronomers call it a flat rotation curve. So, if you plot the distance of a star from the center of the galaxy against its velocity, you kind of have a curve that goes up and then levels off. And, in galaxy after galaxy, she just kept getting these flat rotation curves. And there had been some evidence of this in radio astronomy. And so, there had been people pointing it out. But one thing that one of my sources said to me was, like, she did this in visible wavelengths. She did it in optical astronomy. Like, this is what we can see. This is what we see with our eyes. And because she did it in those wavelengths of light, people started to really say, hey, okay, we've got to take this seriously.
So many things I want to follow up on there.
Yeah. Sorry, that was a long answer.
That's great. So you mentioned the stars farther out are orbiting faster, or at the same speed as stars that are orbiting close into the center of the galaxy. Mm-hmm. So what does that mean? Is it like galaxies acting weird, or something else going on?
Yeah, that's a great question. So, I mean, she was really focused on those observations. And as people started to recognize that this data were real, then they had to come up with an explanation for them. And so what the explanation was that there had to be some other type of matter out there in the galaxy tugging on these stars, pulling them along so that they were moving more quickly than they should be, or that the expectation was. And so that's really kind of how you get this idea that she provided the evidence for the existence of dark matter. There had been mentions of dark matter in the 20s and 30s. Other people had talked about it. It kind of reemerged in the early 70s with some theoretical work looking at how a galaxy was put together. But then her work really kind of put the theoretical work and the observational work together and said, like, okay, we've got these fast stars. There's this idea that there must be some halo of matter around galaxies. This must be what this is like the star's speeds are explained by this halo of matter.
And so how crazy a thing was that for astronomers to learn that, gosh, there's all this stuff out here we didn't know was out there?
I think it was really hard, right? I mean, you've gone a long time, hundreds and hundreds of years, where we're just looking at visible light. Mm-hmm. And then all of a sudden, there's this idea that, holy crap, most of the stuff out there, we have no clue what it is. I mean, that's a really hard concept to wrap your mind around, especially if you're a scientist and you look at things and you collect data and you're observing, and then all of a sudden it's like, oh wait, no, there's something out there, we can't see it and we don't know what it is, but it's there. I mean, it's kind of like the idea of what happened with black holes. The idea of black holes was there was some math, but people said, oh no, like we can't observe it, we don't know how can we actually show that these might exist. And then kind of in the 1970s, right, when Vera was doing some of her work, you had some of the first very convincing evidence of the existence of black holes. And so it just takes a while to make that shift, to say, oh, well, okay, yes, this is a very far out there idea, but here's some data that actually support that it could really be true.
So how you hinted at this earlier, what was the reaction of the community at first to this claim?
No one liked it. No one liked the idea that the universe was mostly stuff we can't see and don't understand. I mean, that's kind of a frightening idea, right? And so, yes, there were always calls for, you need more data, you need to look at these galaxies, you need to do this kind of work, or look at these stars, and Vera just did it. I mean, she just said, okay, like if you want me to do that, that's what I'll do. Sure. And so really then by kind of the late 1970s, early 1980s, people are starting to get on board. And I love, if we're talking about like how to write a book, I got to go to the archives and dig through all of Vera's correspondence, which is an amazing, incredible opportunity. And, I recommend it to anyone. So I was looking for something like, how do I show instead of tell people that she really made this mark in astronomy? And so I'm digging through, and all of a sudden there's this postcard, and it's from one of her collaborators, and he's writing back to her from a meeting in 1980, and he basically says, like, theorists have finally started to accept flat rotation curves. And it's like, oh my God, like this is like one of those things that has to go in the book, because it's like that moment where you're like, okay, I have something physical that I can hang this claim that I have about her being influential and making this discovery in the book. And so I just like love that part that, you go and I find my own evidence for her evidence that, dark matter exists. So anyway, sorry, I probably geeked out really bad there.
No, because I do want to, because this is science writers. So I definitely want to talk about the process of writing the book too. Okay. I want to put a pin in that just for a second, because I do want to just explore Vera as a character for a bit. So yeah, that really jumped out to me from the book, is that her persistence and her tenacity. She presented a couple of galaxies. Hey, these are rotating weird. You need more. Yeah. Okay, here's a few more. You need more. And she just kept grinding for years. Yes,
absolutely. I mean, there was someone who put it like it was 20, then it was 40, then it was 60, then it was 80. And like by the time you get to 100, it's like, okay, we might actually have to step back and say, whoa, wait a minute, we've got a problem here, and we need to address it in astronomy.
And it's not like these are particularly easy like measurements to make. It's not like you point a telescope at a galaxy and it tells you, hey, here's how fast it's spinning.
Yeah, exactly.
I mean, it's a lot of tedious work.
Yes, and I think one of the big things that made her successful is that she was very good at working with people who supported her ideas and could collaborate with her and wanted to foster her work just as much as she wanted to foster theirs. So she teamed up with Kent Ford at the Department of Terrestrial Magnetism, and he had this gorgeous new instrument at the time, right? And it basically was just able to magnify infrared light and really give Vera the ability to collect data on some of these very faint stars in other galaxies, something that had been really, really hard to do up until that point. And so that was something that was really crucial to her being able to make these observations, was having access to that instrument and being able to collaborate with Kent Ford.
Yeah, so you mentioned that. I wanted to ask you what really, one other thing jumped out at me in the book, there are many things, but was just that there were these hints of dark matter going back to, actually further back than I realized, and I'm a space nerd. I learned quite a bit, but there were hints going back to the 1920s that stars were rotating on galaxies a little weird, and in the 30s that galaxies themselves moving a little weird. And it kept, like, with radio astronomy started showing up in the 60s. And so there were these hints just, all the leading up to Vera. And you kind of hinted at it, but I really want to drill on that. So what was it about Vera that, I mean, decades of observations have been hinting that this is a thing, but Vera just blew the doors off it.
Yeah, I think there were two things. I think the first thing was that she was working in optical wavelengths of light, the light we can see. And I think for people, that radio astronomy was really new at the time. It was, kind of not well understood, I would say. People didn't really understand what they were looking at, but because so many people could use their eyes to look up at the night sky, they almost trusted observations like Vera's from optical telescopes more than radio data at the time. And so I think between that and the fact that she really did go after all types of galaxies, that she did this in so many different kinds of galaxies, and the observations always held up, that I think it just got to a point that there was no denying it. Her evidence really just pushed the astronomy community to have to say, okay, we can't ignore this anymore. Yeah, before it was a couple galaxies or a galaxy cluster that was awkward, but she has really done this to a full extent, and really shown that these flat rotation curves, these fast stars far out in the galaxy, are universal. I mean, that was something that caught my attention, is just how she was revered for showing that this behavior was ubiquitous in the universe and galaxies.
I want to pivot a little bit. You're talking about she's already going up against trying to convince everyone this thing you can't see, no, it really exists. One of the our participants has a question, and it's definitely something I want to explore. And she's asking, what was it that made Rubin successful in a male-dominated field? I know you talk about that quite a bit in the book, because mid-20th century astronomy wasn't super friendly to women.
Yeah, I think that's an excellent question. And I think it was actually something that Vera sorry, I refer to her as Vera. I hope that's okay. That's something she talked about a lot, in that she really was a proponent of finding the people that were willing to help you, and the people that were willing to collaborate with you, and just kind of blocking out everybody else, just ignoring the haters, essentially, and really kind of fostering those collaborative connections that she had. So, even going back to, I would say really in graduate school. In undergrad, she was kind of on her own. She was at Vassar. She was the only astronomy major. There was one woman who helped her a bit. But I think then it was kind of in undergrad, she met her husband, who would become her husband, the man who would become her husband. And I think he really supported her. He was kind of the first. They would sit and, she had a crush on Richard Feynman, which Maria Temming pointed out when we were doing our talk, that she thought was kind of a cool thing. And
I have a crush on Richard Feynman. So.
and then Vera meets her husband at this kind of dinner that her parents set up for them, and she's talking with him, and he says he's a student of Feynman's, and of course Vera's immediately intrigued. And so she ends up, they get married, and she ends up following Bob to Cornell to do her master's in astronomy. And it's really there where she starts to meet the first people who are willing to help her. And it's not her astronomy advisor. He was not very helpful at all, I would say. But her husband's very supportive. Richard Feynman's very supportive. And then they have a woman on faculty named Martha Starr, who actually was able to use one of the observatories out in California during World War II, because most of the men were off at war. And so, she kind of sees Martha Starr and like, oh, okay, women can be in astronomy. Okay, this is possible. And then they talk about her ideas and what she wants to do, and she starts working on her master's thesis, and so that kind of helps her get a start, so to speak. And then they move to DC, and again, she starts to surround herself with people who will help her. George Gamow is one. Ralph Alpher is another. He works with her husband, and so she just kind of puts together this team, and you have to credit the personality of the people who helped her. Especially the gentleman at Georgetown, and I can't think of his name right now. Sorry, drawing a blank. But anyway, Father Hayden, that's who I'm thinking of. But anyway, you have to credit the personality of some of these male figures, because some of their colleagues are saying, oh, we don't want to work with women, they can't do this. But they're saying, no, like, let's foster her ideas. Let's see what she brings to the table. Let's see what questions she asks. And she really taps into that. And I think that's what helped her be successful, is she didn't listen to the critics and really focused on the people who were there to help her.
That's wonderful. Haters are going to hate. So.
Yeah.
I actually want to drill down on it, because I was reading the book. Like, I knew mid-20th century astronomy wasn't always friendly to women, but some of the stories in the book were just like, you gotta be kidding me.
Yeah.
Can you, I wonder if you could share a couple of things that really jumped out at you? And one of the things for me was the bathroom at Palomar. It was like,
yeah.
I don't know if you could share some of those things.
Yeah, sure. I mean, again, kind of going back to her graduate days, she shows up on day one, and her astronomy advisor essentially tells her to go find something else to study because there are too many astronomers. Welcome to grad school. That's a great way to start. And same guy then wants to present her research at a meeting and under his own name. Like, again, not the greatest way to start. And what I love about Vera's story is, like, she just kept saying, like, no, I am going to present my work. I don't care that I just had a baby. Like, I am going to go do this because I care about it. And it's my work. And you kind of wrote me off from the beginning. Mm-hmm. So, so there's that story. There aren't a lot of opportunities for women to go and observe. Kind of in the beginning of her career, she has to use a lot of data from male astronomers, and they won't give it to her. I mean, there are, access issues for her getting the data that she needs to answer some of the questions that she wants to ask. And she finds ways around that. And then you're right, like she goes and she's observing at Palomar, and the guy's like so focused on this infamous bathroom, and you're just like, oh, okay, like it's a bathroom, it's not a big deal, like everybody can use the bathroom.
And
But anyway,
for folks who don't know the story, what is the bathroom?
Yeah. So when she goes to Palomar, there's only one bathroom because that observatory had been built for men. Women didn't use it. And, there were just no facilities for women. Mm-hmm. And, when she's being shown around the first time, when she's there in the 1960s, this guy makes this huge deal about showing her this male bathroom. And I mean, eventually later she becomes a bit cheeky and she just like cuts out a picture of the little stick figure of a woman with the skirt and like pastes it up there. And it's like, oh, well, now it's a female bathroom, it's fine.
I love that little story.
Yeah. I mean, that's what I love about her is like, she just gets this gumption. Like she's not going to take anybody's crap, basically. Which is maybe a good lesson to remember.
Yeah, it just surprised me. Like she was being told, like women were not allowed to at observatories. It's just for most observatories, a couple were, but it's just.
Yeah, I mean, they really weren't. I mean, Margaret Burbage, her story is so fascinating because in the relationship with her husband, she was the astronomer. She had the background to use the telescopes, but he was granted the telescope time. So what they did was she essentially said she was his assistant, and then she would get to go and use the telescope. So, I mean, finally in the 1960s, they do start opening telescopes to women, which is very helpful for Vera. But there was just a lot of hesitancy, and I don't think the bathroom was the issue. Like,
Yeah. And I'm glad you brought up Margaret Burbage because I really like it. Throughout the book, you are bringing up these other women astronomers, other women trailblazers. And I wonder if you could talk at all about some of Vera's role models. I know she had one when she was when she was young. It was, what was her name?
Mariah Mitchell. Yeah.
Mariah Mitchell, sorry.
Yep.
What was her story and how that inspired Vera?
Yeah. So Mariah Mitchell was, she started observing with her father, and, very well educated. She was a Quaker. So her father believed that even in the 1800s, that girls and boys should be educated the same, have equal access to the sciences and math. And so she, had this proclivity for mathematics. And so her dad started having her help him observe. And eventually then she would just go and observe. And there was one night she was up on the top of the bank there in, Massachusetts, and she's looking up and she sees something really odd. Like, she's thinking that it should be a planet, but it doesn't have the quite the right capability, quite the right characteristics. And as she starts looking at her star charts and kind of digging in a little bit more, she realizes like this is a comet. And the King of Denmark had said to the first person who observes a comet with a telescope, so one you can't see with the naked eye, he would award a gold medal. And so Mariah Mitchell was a little hesitant to talk about her discovery, but she eventually writes down her calculations. And the president of Harvard at the time said, you should submit this to the king and there could be a gold medal. The gold medal had actually been given to a man, even though she had observed it first, but because of the way communication worked then, they didn't know about her discovery. And so I think what was very classy of the king was he said, oh, well, she did observe it first, so I'm gonna award her the gold medal as well. And so that kind of cemented Mariah Mitchell as the first professional woman astronomer in the United States, and really kind of put the US on the map for astronomy, because prior to that, Europeans had kind of been snooty and said, oh, well, those Americans, they don't know what they're doing. And so, so her story becomes kind of this legacy, and she ends up going to Vassar and starting an observatory there. And Vera learns about her story when she's younger, when she's doing some research on Ben Franklin and Newton and kind of some of these other bigger names. She stumbles across Mariah Mitchell's story and kind of latches onto that and says, okay, like this is something that women do just the way men do. And so I think that is one thing that draws her to Vassar. And then, kind of her story goes on from there. She meets Martha Starr when she goes to Cornell. And then it's really, she had always admired Margaret Burbage, just because, she was part of the big paper about how stars create their energy, and, she knew of her. And so then in the 1960s, Vera's husband has a sabbatical and can kind of go anywhere. And he makes this beautiful choice to go to a place where Vera will also have collaborators to work with. So she gets to go out and work with the Burbages and the Hoya. And that's kind of where she really learns to do the observations that she'll do that will kind of put her on the map for finding this evidence of dark matter.
That's great. Just want to remind everyone who's on the call, if you have any questions, please drop them in the Q&A. I'm sure Ashley would love to hear from you. What struck me is Vera later in life really did pivot to becoming what's the right word, like a spokesperson or a fighter for women's rights in astronomy. I mean, she really took on that mantle, it seemed. I don't know if you could talk a little bit about that pivot, what finally, like in her brain, says, I need to do this, and what sorts of things was she doing?
Yeah, I think that's a great question. And I was kind of thinking about that a bit more before this call. And I honestly think one of the things that fueled her to become such an advocate was watching her daughter face the same barriers that she faced 20 some years later in astronomy. Her daughter had a really bright career, but she kind of faced all these roadblocks that Vera faced. Like, she wanted to get married while she was doing her graduate work, and her advisors, this is Judith Rubin, her daughter, her advisors basically said, well, if you're going to get married, you should just quit astronomy. Like, you should just give it up. And I think that really grated on Vera. Like, there had been these women, there had been these changes, and yet her daughter still faced the same kinds of comments. And I think at that point she was like, okay, now I really need to stand up and use my voice, because we're not making any progress. Like, yes, there might be more women, but we're still facing those same kinds of derogatory remarks and inappropriate remarks. And it's kind of not fostering the environment that we need to be successful. And so in the 1970s, early 80s, that's, I think, where she really finds her voice and starts to speak up.
Did you come across anything was she getting a pushback on that front from the broader community for taking on that role?
Yeah, she had a lot of people tell her, don't do this, it'll ruin your career. Like, you'll jeopardize your career by doing this. And she didn't listen. I mean, that's very kind of standard for her.
That's a theme in her life.
Yeah. And I think it was just something that she was like, no, this is really important to me, and I'm going to stand up and I'm going to fight for what I believe in. And she did. And it didn't hamper her career. I think it actually kind of filled out who she was as a person and kind of gave us a better sense of her character.
She was also, jumped out of me in the book, is she was also very passionate about education too. And you tell a great story in the book about, is in the basement of the Smithsonian, somewhere in the Smithsonian, with a bunch of kids in like a metal bar or something, where someone have full Uh, can you, I don't know, can you mind sharing that story? Because I do like it.
Yeah, sure, sure. So she is trying to, she was going to give a nighttime lecture there about her work. And they had invited a bunch of students to come. And she was a bit concerned that maybe the students wouldn't understand unless there was a hands-on activity. And so what she did was she took the students, with their teachers down in the basement, and there was lots of rooms. So she had the kids kind of spread out, and each kid was a star. And there were some stars that were closer into the center of the galaxy.
Mhm.
And then there were some stars that were farther out. And she essentially had them start to rotate like they were a galaxy. So just start walking. Well, pretty soon, the stars or the kids farther out are kind of lagging behind because they have farther to go. And so then she tries to explain to them, okay, that's not what I observed. Here's what I observed. So she had them stretch out in a line, and you probably have 5 or 6 or 7 rows of kids, and they're all going to start walking around, but she gives them this metal rod to hold, and they have to stay in a straight line. And so then she says, go, and the kids start walking. Well, the kids at the end have to run to keep up. And so I think for them, it finally made sense about what she was talking about, that these stars farther out have to move much faster than the stars closer in to keep up. And there's got to be something that's driving that. And so I think she was very good at finding ways to explain that, even to people who might not understand kind of what dark matter is, or understand the complete structure of a galaxy, or even know that much about astronomy. I mean, that was the beauty, that she really was a great science communicator as well as a great scientist.
So I have to, I'm going to take host's prerogative and insert my own little story into this, because I met
Yeah.
Vera once when I was a grad student. I was at Lowell Observatory. And of course, I'm thinking about that meeting the whole time reading your book. And then at the end of the book, you actually talk about her very last observing run at Kitt Peak Observatory, but she was hanging out at Lowell Observatory with one of her collaborators, and she was helping with some outreach to teachers on the Navajo Hopi reservations near Flagstaff. I was at that meeting. I was in that room with her.
Oh my gosh, that's amazing.
Because I joined Lowell in 2008, and I was
Okay.
part of that program, outreach to the teachers on the Navajo reservation. And that is my one memory of Vera, is we're just like, I don't know, there was like 6 of us, maybe astronomers, and then maybe an equal number of teachers from the reservation. And Vera Rubin just there, chatting with the teachers and talking about her experiences. The teachers are talking about the challenges of teaching science in the reservation and the cultural challenges they're facing. And sure, of course, she's bringing in all these stories you're telling about how she had to convince people. And it was just a really wonderful memory I have, the only one I have of her. But I saw that at that actual meeting in the book.
Yeah, that's amazing.
I was there. Before we get to talking about like the book itself, like the process of writing the book, I did want to touch on much has been written about the fact that Vera never was awarded a Nobel Prize for for her contribution to discovering dark matter, and despite many thinking that was a travesty. I'm curious, because you also got a chance to spend some time with her as well. Like, did you get any sense of like what her thoughts were on that, or what thoughts were from people, other astronomers on that?
Yeah. I think when it comes to astronomers, there's kind of mixed group of people. There are some people who are clearly, yes, she absolutely should have won the Nobel Prize. There's the saying, she or he who proves discovers. And essentially she kind of convinced the astronomy community that dark matter had to exist, and therefore she proved, therefore she discovered, therefore she should receive the Nobel Prize. But then there are kind of another subset of astronomers who say, well, there were so many other people, there was so much other work going on, she kind of just was along for the ride, so to speak. And so I think there's a kind of a lot of debate going back and forth there. But I think for her, I know that she considered it. I know that she thought about it. And maybe she did think that she deserved it. But I think one of the things that I found, I never talked to her directly about it, but I did have a conversation with her sister about it last summer. And what she said to me was that the conversations didn't center so much about Vera winning the prize as what it did to your life once you won it. It essentially changed who you were if you let it. And I think that was Vera's bigger concern, that the prize would somehow change her and kind of shift her focus from the curiosity that she had to something else, perhaps vanity, I don't know. But that was what stuck with me about that conversation with her sister, was Vera was more concerned not about winning or not winning it, but what it would do to her and how it would change how people thought about her or how she would approach her work. Mm-hmm. Which again, I think is a very interesting testament to her character and the way she thought about things.
Yeah. I thought it was really interesting. You talked about in the book how she got involved with some other research in quasars. It's kind of like super luminous cores of galaxies on the other side of the universe. And she got out of it because it was just going too fast and she couldn't take the time to like do it right. I thought that was such an interesting insight into her as a person and as a scientist.
Yes. Yeah. I think she was just very worried about making a mistake. She did not like that. I think she kind of held on to some of the criticism that she got when she was a graduate student, and people were very dismissive of her work about, she had asked the question about whether the universe rotates or not, and found some very interesting data that might suggest there was some unexplained motion, and it was not well received. And so the biggest criticism she got was always, collect more data, find more data, you need more data. And I think with quasars, because she didn't quite have the access to the telescope that some of her counterparts, male counterparts, did, she couldn't check, she couldn't verify, she couldn't do the work to the level that she wanted to do. And so that's why she chose to go and look at how stars rotate around galaxies, like how do they spin? She thought that would be much more quiet and peaceful. Little did she know that that was not the case.
We have a question from the audience. And someone's asking if your reporting led you to any other unsung heroes in astronomy, particularly any of those that Vera herself inspired.
Oh, that's an interesting question. Gosh, I think there are a lot. I mean, I talk a little bit in the book about Sandra Faber, who was awarded some prizes later on, but I still think is someone who might not be as well known for her work. The other one would be Margaret Geller for large scale structure work.
So what did Sandra Faber, what did she work on?
She's had a lot of different projects. I think the biggest thing, one of her questions early on was the interaction of galaxies and kind of looking at, is there any evidence for dark matter and how galaxies interact? And then she kind of did a lot. I think kind of her focus was really in working at Keck Observatory and building some of the instrumentation and kind of getting that observatory off the ground. And really kind of being one of the first women faculty in some of the universities in California. There's actually correspondence. Vera wrote her letter of recommendation for her position in California, and it just kind of talking about how they had interacted and kind of how influential Sandra Faber was in all of these kind of bigger research questions about galaxy interactions and kind of I'll just stop there.
Did you kind of second part of that question, did you come across anyone who really was inspired by Vera, to much like Vera was inspired by Mariah Mitchell? Did anyone follow in Vera's footsteps and said, hey, I can do that because Vera can do it?
I think there were a lot. I think there were a lot of women that we don't necessarily know their names yet, but who are very influential. I mean, I know Sarah Yeager, who is a famous exoplanet scientist, interacted with Vera at the Department of Terrestrial Magnetism. I think Alicia Weinberger is another one. There are just so many that will say, like, I became an astronomer. I believed I could become an astronomer because I read about Vera. Yeah, I mean, I think the list could go on and on,
Yeah.
including her own daughter.
Right. Yeah. Yeah. I want to pivot a little bit because we have about 10 minutes left, and the phone lines are still open, everyone. So please put in your questions. I do want to talk a little bit about, since we're with science writers, about the process of writing the book. So how did this book actually come about?
That's a great question. So it started originally as me just like noodling around, first in the Air and Space Museum, and then getting the opportunity to go and interview Vera. And then I went to MIT to do my graduate program in science writing. We had to have a thesis. And when you go, you bring kind of 4 or 5 ideas that you've written out. And as I was presenting my ideas, my advisors got kind of stuck on this one. And it was interesting because the woman who would be my advisor, Marcia Bertusiak, had actually written about Vera. And so it was kind of like, oh, well, what new things can we bring to the story? Where the other advisors had said, like, oh, we don't know anything about this woman, we want to know her story. So I thought that was kind of an interesting thing. I didn't think a lot about it. And I really didn't think that this would become a book at that point. I was just trying to like graduate grad school and launch a career in science writing. So I wrote the thesis. I didn't really think anything of it. One thing I did do, though, MIT was very supportive about traveling for your thesis if you could. And so I got in my mind that Vera would definitely say no, but I would ask anyway if I could go to the telescope with her. So I got up the gumption. I drafted out this letter to her. There were several drafts. And I finally sent it, and she called me because, she was kind of more old fashioned, like just called me up. And she was like, absolutely, you can come to the telescope with me. And I was like, wait, are you sure you're talking to the right person here? Okay. I thought you would say no, but okay. So that became part of the thesis, and kind of gave you that lovely description that I have in the beginning of the book. And so anyway, I finished that. I graduated, didn't think anything about her story, which I regret. I wish I had been braver, I guess I would say. If there's anybody thinking about working on a book, just go for it, because I wish I had been braver and started sooner and kind of not let things chance, but I did. And so Vera passed away in 2016. At that point, I was like, well, I'm pretty credible. I guess I could write some of her obituaries for different sources, which I did. And then again, I didn't think anything of it. And I should have thought, you have all of this material, why not put a book proposal together? But again, I was too afraid. And so I'm going to reiterate this. If you have a book idea, just go talk to someone, go get help, because it's so worth it. And I wish I would have done it. Anyway, all that to say, I was minding my own business in 2018 and got this random email in my inbox that said, hey, we're starting a Women in Science series at MIT Press. We read your thesis. Would you like to write a biography of Vera Rubin? And once again, I was like, is this fake? Is this spam? Like someone pulling my leg? Is this real? So, after some investigation and digging into the email, I was like, okay, obviously this is legitimate. And so then from there, working with the academic press, I had had to put a proposal together, which you typically do have to do for a book, which I did. And then they actually sent it out for peer review, which was terrifying. I'm not a scientist, so for you, Chris, like peer review is probably old hat. But for me, I was like, oh my God, like there are going to be scientists reading and critiquing, and they'll probably say no. And so I survived that process, and it was terrifying. And there were lots of comments that I had to accept and move on from. And so once that came back in, there were actually some comments that were super helpful in kind of formulating how I would approach the book. And, you know, again, we kind of negotiated all of these things. I had never done it before. So I actually called Tom Siegfried up and was like, I don't know what I'm doing. Can you help me? Which he was very gracious to do. And so then we, you know, finally got the contract. And then after that process, which took probably about a year, they were like, okay, time for you to write the book now. And I was like, oh my gosh, can I rest for a minute? Because that was a lot. So then that was kind of 2019 was once we finally had gotten the contract together and gotten approval and gotten started writing. And I essentially had 9 months to write the book by then. maybe a couple more, maybe a year, but not much. And so then I just had to kind of put my nose down and start working.
So I get stressed writing a 3,000 word feature. So what was it like to report and write something of this scale?
Yeah.
What was like?
Fortunately, they capped me at 60,000 words.
Okay.
So I was like, oh, okay, that's a lot. That's a lot of words. But it's like not that I have to write an 800-page David Copperfield kind of book, which is good. I was like, okay, that's less intimidating. And as I started thinking about the process, I had learned something when working at The Scientist, which I think was really helpful. This was one of the editors, Carrie Grenz, helped me with this. She, for her writers for news and features, had come up with this idea of creating like nested deadlines. So instead of trying to swallow the whole piece and sit down and write in one go, you kind of break it into chunks. And so what I did was I calculated out how many exact days I had before my first draft was due. And then I calculated how many words do I have to write per day to meet that deadline. And once I had that figured out, then I was like, okay, that's what I'm going to do. That's going to be my goal, is every day. I think it was something like 300 words, which is totally manageable. You sit down, you write 300 words. And before I knew it, like, you know, I had half the book written. I was like, okay, this isn't horrible. It's still stressful, but it's not horrible. And I kind of just kept chugging along. And in the meantime, sending chapters to different people to help read, which they graciously did. I had a lot of help with this book. And so I think that was the biggest thing, was really kind of breaking it down into these bite-sized chunks that I could manage and not feel totally overwhelmed by the whole project.
Yeah. What sort of, can you talk about, like, how did you figure out like the big picture structure of it? Because there's a lot of threads here. There's your personal life, your scientific life, and you dive deep into like the science background of things. And like, how did you deal with that, I guess?
Yeah. It was kind of hard, but I had talked to someone about how to structure the book very early on. This is Carl Bates. And he was my old boss at Duke, and we had talked about it, and he kind of said, well, why don't you make it a bit like the Titanic, right? Start with her as an older woman, kind of reminiscing about what she did, and then go backwards, and then work all the way back up to her being an old woman. And you know, you can kind of pull on these threads of her memories of different key events in her life. And I thought, oh, well, that's a great idea, actually. And so then from then I tried to keep things chronological. So like if there was a part of her life that was happening, and then there was also some key aspect of astronomy that we needed to understand that was happening at the same time, I tried to weave those together.
Mhm.
I am still not convinced that I was like masterful about it, but that was kind of the thought process I had, is keep things kind of parallel time wise so that readers have a sense of her background and then also a background in what's going on in astronomy, so that when you get to the 1970s, you've got all these key pieces of information that you need.
Yeah, I think it worked really well because, yeah, it gives you some comparison, some context for where she was in her life, what was going on in the world of astronomy at the same
Right.
time. So yeah, when you hit the late 70s, it all
Yeah.
kind of comes together pretty magically.
Yeah.
We do have one, I know we're getting close to the end, but we do have one question in the Q&A mentioning that 300 words per day is very doable. How much time, like extra time though, did you need for research and figuring out like these organizational questions?
That probably took longer. I did have times where I would have to write maybe 600 to 900 words a day because I had spent 2 or 3 days doing the research that I needed to do. And so it kind of, I had to balance that. But the research always took longer than you think it was going to, because you end up going down rabbit holes, as most science writers know. You're like, you read this thing and then you read this other thing, and then before you know it, your night, which was typically for me from 6 to 10 p.m., that's what I would do my writing, was gone. And I was like, oh crap, I did not write a single word. So I did kind of have to factor that in and say, and be very disciplined with myself and say, okay, this week you spent a lot of time on research. On the weekend, you really need to buckle down and write all of the 300 word chunks that you missed during the week.
But we are at 8:01 p.m. and I haven't gotten to half the questions I had. So,
well, I am happy to answer any questions anytime.
So I want to respect everyone's time and your time. But I just want to kind of, we could wrap things up, asking, going back to Vera, in your reporting, what kind of, what's the question? What like impression, or what did you come across anything that really surprised you about her, or anything that just left a really lasting impression on Vera as a person?
Yeah, I think about this question a lot, and it's actually something that I don't know that I nailed hard enough in the book. But I think what I want people to remember about her is like, she wasn't just an extraordinary scientist. She was an extraordinary human being. Just the way she acted with people, the way she listened. I mean, I was 22 when I met her. I was fresh out of the University of Tennessee, which great school, but not Harvard, not Yale, not Cornell. And yet she took the time to sit and ask me questions and be curious about what I was interested in. And when I said I wanted to be a science writer, she was like, that's lovely. Let's think about ideas about how you can be successful. She didn't have to do that. I mean, she could have totally just blown me off. And so what I really appreciate about her is she made time for people, even if they weren't scientists. I mean, she listened, she was curious, she asked questions. She was the type of person that I wanted to be and want to be still. And it didn't matter that, she essentially provided evidence for the existence of dark matter. Like, she was just a beautiful person.
Well, that sounds like a wonderful note to end on. So I want to thank everyone for joining us tonight. This was a wonderful conversation. I learned even more about it, about Vera Rubin. The book is out now at anywhere you can buy books, right?
Yep. Anywhere you can buy books.
So please pick it up, support Ashley. And Ashley, thank you so much for taking an hour out of your night.
Yeah. And if people have questions, I mean, I'm happy if they email me. I'm always happy to chat more and help people as best I can. I think that's what Vera taught me. So I'm going to kind of pay it forward.
Wonderful.
So anything anybody needs, just let me know.
Well, thank you so much. Thank you, everyone. And have a wonderful night.
Yeah.